Hello, today we'll be going over problem 4 of the CodeChef July Long Challenge 2020 Division 2, Missing a Point. So the problem statement is that Chef has n-axis parallel rectangles in a 2D Cartesian coordinate system. We'll be talking a little bit more about what this is a little later on. So there's guaranteed that there are 4 n vertices in total that are pairwise distinct. So Chef has lost one vertex over here, and up until now, none of his fixes have worked. So you are given the task of finding the missing point. So you're given the remaining 4n-1 points, and you should find the missing point. Now let's go over the solution to the problem. But before we go over it, I want to clarify some definitions that would be extremely helpful when solving this problem. First, the problem statement states that Chef has n-axis parallel rectangles in a 2D Cartesian coordinate system. And the big phrase I really want to focus on is axis parallel rectangles. So what does this mean? It means that all the sides of the rectangles are parallel to either the x or the y axis. So for example, over here on the left hand side of a Cartesian plane. So say I plot down these points over here, and I draw out this rectangle. This rectangle is an axis parallel rectangle because we see if we look at the bottom side, it is parallel to the x-axis. If we look at the top side, it is also parallel to the x-axis. If we look at the left side, it is parallel to the y-axis. And if you look at the other right side, it is also parallel to the y-axis. Therefore, all sides are parallel to one of the axes. Now, if you look at an example of a non-parallel rectangle, for example, say we draw these points here and draw out this rectangle, we see that none of the points in this rectangle are really parallel to any of the axes. So the one on the top is an example of a non-axis parallel rectangle, meaning that none of its sides are parallel to the axes. So let's real quickly focus on the first rectangle she drew, which is an axis parallel rectangle. Let's look at some of the points. One observation which we can make is that there are 2 points that lie on one x-coordinate, 2 points that lie on another x-coordinate, 2 points that lie on a y-coordinate, and 2 points that lie on another y-coordinate. And the reason why an axis parallel rectangle really helps with this problem is because if you look at a non-axis parallel rectangle, let's look at the points. 1 point on an x-axis, 2 points on a y-axis, another point on a different x-axis, a third point on a different x-axis, and everything just starts becoming more complicated if it's not axis parallel. Because now we have 3 points on 3 different x-axes, and then here we have 3 points on 3 different y-axes. So it becomes a lot more complicated with non-axis parallel rectangles. So let's go back to a regular axis parallel rectangle. So here we've noticed that there are 2 points on each y-coordinate, and there are 2 different y-coordinates, and 2 points on each x-coordinate, and there are 2 different x-coordinates. The x-coordinates are 1 and 5. The y-coordinates are 1 and 4. So here we can make the observation that every single axis parallel rectangle will have 2 different x-coordinates. For each x-coordinate, there will be 2 different points on it, and 2 different y-coordinates. For each y-coordinate, there will be 2 different points. So now, given 4n-1 points, if they're all axis parallel rectangles, we just need to look at the different points we have. So now let's go over the solution to this problem. So let's say in this rectangle, we take away the top right point. Then the coordinates we have left over are 1, 4, 1, 1, and 5, 1. Now immediately I can tell that the solution which we're missing is coordinate 5, 4, which is the top right coordinate of the rectangle. So now the way I get this is because we know that, so here on each point we saw that at x coordinate 1, on the line x equal to 1, there are 2 points. On the line x equal to 5, there are 2 points. On the line y equal to 1, there are 2 points. On the line y equal to 4, there are 2 points. But here, if we look at the coordinates, we see that on the line x equal to 1, there are 2 points. However, on the line x equal to 5, there's only 1 point. Therefore, there has to be a second point on the line x is equal to 5. So we know that the 5 has to be in the x-coordinate. Now, if you look at the y-coordinates again, if we look at the line y equal to 1, there are 2 points on it. But if we look at the line y equal to 4, there's only 1 point. So therefore, we know that a 4 also has to be in the y-coordinate spot to fill in for that point. So now we can find find our solution as 5, 4. And you can do this for anything, for all rectangles. And one thing which you need to keep in mind is that on each line, for example, x equal to 1 on this line, we saw that there are exactly 2 points. However, all we need to know is that there is an even amount of points on this line, because the thing is, there can be multiple rectangles. Say we draw another rectangle just a little bit higher of the exact same size and type. Then, in this case, we see that there are 4 points on the line x equal to 1, namely this point, this point, this point, and this point. And there are 4 points on x equal to 5. This point, this point, this point, and this point. So therefore, we just need to see that there's an even amount of points for each line on the x-axis and for each line on the y-axis. And we can easily solve this just the way we solved the example as seen over here. So let's just go over one more example where in this case we have the 2 rectangles we drew and we're missing the point 1, 7, which is the bottom left point of the second rectangle we drew. So on the right hand side, I've written down all of the points of the other rectangles. So let's go over how we can find this missing point. So let's just focus on the x-coordinate. We see that we have 3 ones. Now because we do not have an even number of ones, we can immediately tell that the x-coordinate will consist of a 1. Because remember, on each axis, for each rectangle, we have exactly 2 points for each of the 2 x-coordinates, and 2 points for each of the 2 y-coordinates. So there must be an even amount of points total on the x-axis and y-axis. And if we look at this more closely, we see that for the coordinate of 5, we have 4 5s, which is an even amount of 5s. There are 4 5s. We do not need to put another point on the coordinate for 5. So now we found our x-coordinate. How do we find our y-coordinate? We look again. We first check 4s. We see that there are 2 4s. This is an even amount. Therefore, we do not need to place our y-coordinate on the point 4. Next, we can check 1s. We see that there are 2 1s. Therefore, we do not need to place our y-coordinate on the 1s. Then we check again. We see the 10s. There are 2 10s, an even amount of 10s. So we do not need to place our y-coordinate on the 10s. And then we come across the single 7. And there's only one single 7, so you know that that must be the other coordinate because we're missing another pair for that 7. So then we got to answer 1, 7. And if we look at the point, we do see that this point is 1, 7. So this is how we can find the missing points. Now let's go over the code implementation of the solution. So in the code, I'm just going to go over each line step by step of what each line does. So here we have our integer t, the amount of test cases, and then we input into t. Then for each test case inside this while loop, we have our integer n, and we're going to input into n. Now the total amount of vertices which we are given in the input is 4 times n minus 1, because we are asked to find the missing vertice. So we can just set that equal to some number k for convenience. Then we can create 2 long arrays. One for the x-coordinate, which I've written with the variable name a, and one with the y-coordinate, which I've written with the variable name b. So then, in our for loop, we can take in the input. So from I equal to 0 to I equal to k, we're going to input into the x-coordinate, then the y-coordinate. Then we're going to go over here to these 2 lines of codes and sort both the x and y coordinates. This is mostly for convenience and will help us code the rest up much easily. Because what sorting does is that, say we have lots of different x coordinates. We can group all of the x coordinates of one number together, all of the x coordinates of another number together, all of the x coordinates of a third number together, and so on. So this can help us keep organized and group all of the different types of x-coordinates together, and same for the y-coordinates. Now what this really helps us do is that when we go through the array, so for each vertice, from I equal to 0 to I equal to k, we're going to check each pair of numbers. For each pair of numbers, we're going to check one number, then the number right after it. Now what we want to see in an axis parallel rectangle is that both should be equal. Because remember, in an axis parallel rectangle, we had an even amount of points for each x-coordinate and for each y-coordinate. So we can check every single pair for the even amount of coordinates. Now what happens when we don't find a pair is that we immediately know that the missing coordinate is the x coordinate. We can print it out and break. So just to go over a quick example here, say we have the test case 4, 4, 4, 4, 3, 3, 5. 3, 3, 3, 5. So sorting this yields 3, 3, 3, 4, 4, 4, 4, and 5. So now in our loop, we're going to go through the first two numbers, a 3 and a 3. We're going to check. They're equal, so we won't do anything. Then I is going to plus equal 2, and we're going to move on to the next set of numbers. So here, in an axis parallel rectangle, if this is a 3, there should be one more 3 to form the pair, as we've seen in our solution. However, there's no extra 3. It just becomes a 4. So then this statement runs, and then we're going to print out a at position I, which is this 3. So, therefore, we know that the missing coordinate is the x coordinate, which is the x coordinate 3, which is indeed true. Now, what we're going to basically do is copy and paste this code and run the exact same thing, except flip it around for the y coordinates. So instead of if a at position I is unequal to a at position I plus 1, we'll do b at position I is unequal to b at position I plus 1, and then we can easily just print out the x and y coordinate. Then we are done with the code.